Okay, hello everyone. Session 3 here, and under the nice climate of Nice, we're going to talk about blue tech and aquaculture. So, session for science and society students, starting with Axel LE Lay, already here, then Fabian, and after the break at 3:50, we'll start again with Adrien and Nichele. So we're going to talk about blue tech and aquaculture, and we'll go to France, Norway, and the Philippines. Thank you to Darwin Evolution, Seaweed Solutions, the Climate Foundation, and Aquafrecan for welcoming our students. The reviewers of your papers in this session were, and thank you to you, Juliette Armeni, Project Manager at Polymer Méditerranée, also here part of the jury online, Electra Atinawi, Project Manager at IC from Greece, Hubert Bonnefond, CEO of Darwin Evolution. You will have realized that Hubert is also here for the jury. Robin Fayetaz, researcher at Ifremer in Lorient. Stina Kolodze, postdoc at Aarhus University in Denmark. Nadir Lafayette, PhD postdoc at ICN Université Côte d'Azur. And Joseph Rauch, project manager at the Climate Foundation. Voilà. So the jury members, Juliette, Hubert, Louisa, and Eric will be chair. T'es prêt already?
Yes.
Allez, so we go. I just turn that. And magically, you can use 15 next minutes just for you. I guess you might be interested of having the slides also shared, if you want.
Yes.
Yeah. You have the floor.
Here. Yes.
I can adjust in case.
Yeah. Okay. Good.
Yeah.
Okay. Thank you everyone for being here. I'm Axel Le Lay, and today I will present my research on sustainable aquaculture at Aquafrecan. So over the next 15 minutes, I will cover the global challenges driving aquaculture, the environmental conditions we have at Aquafre, as well as our objective, the hypothesis, methodology, the expected results, and the recommendations for the future. But before that, to give a very global context, aquaculture is booming, and it recently surpassed the capture fisheries for the first time in history in 2022. And this is due to two main reasons. The first one being the decline of the fish stocks in the wild since the 60s, and a rising global fish consumption. You can see on the second graph, it's rising for everyone and even booming for countries like China that went from 5 to more than 40 kilos per person per year. France is a great consumer, way above the average European country or even United States. And this increase translates the need for protein for a growing population. But by getting bigger, the aquaculture also raise environmental challenges like nutrient runoff. Here, this is due to inland farm. So that's a big algal bloom, but getting bigger, aquaculture could have similar impacts. Finally, the projections for the future are predicting declining oxygen levels. So this highlights the need for sustainable practices. For that, I went to Aquafrecan. They are French producers of sea bass and sea bream, and they are using traditional methods, so sustainable methods. Here, we use data-driven management techniques to focus on the sea bass and sea bream production. And at their site and location, the most affected fish is the sea bass. That's why I will focus on it. Most of you already know and probably even tried the sea bass, un loup ou bar en français. It's a very abundant species in the Mediterranean. And a nice fun fact is that the south of France, and Cannes in particular, was a leader in their hatcheries techniques in the 70s. And they established the first hatcheries technique. And now the sea bass is one of the most commercialized fish in Europe, but it faces growing environmental challenges. From the literature, we have a lot of research on salmon due to the large scale of the market. You can see on the bottom, salmon market is more than 10 times bigger than the sea bass market. Therefore, receiving less attention, the sea bass has limited to no studies that integrate the oxygen monitoring with feeding schedules, and our study aimed to fill this gap. The oxygen levels, in particular for the sea bass, from the literature, we know that oxygen levels impact the growth, the welfare, and the metabolism of the fish, but also that having hypoxic levels increase the stress, reduce their growth, and immunodepress the fish, making them vulnerable to disease. And finally, we know that optimal levels can improve the feed conversion and the digestion for the fish. Here on the right, you have the colors that will be used later, and this is from the scale that we could evaluate when our fish are under stressful moments. So the problem at Aquaculture, for years, they had issues in the summer with their sea bass, and they asked analysis of the environmental conditions. It was done by Biosanor in 2024. And what they found is that the temperatures are higher each summer and stay here for longer periods. But the oxygen is also negatively linked to the temperature. So as you can see on the graphs, we have very challenging conditions in the summer for the oxygen. To develop a bit the issue, their study revealed that our conditions are not good for the sea bass, as it reduces their appetite and therefore their growth, and it exposes them to disease like nodaviruses. If we zoom in, we can see on the vertical axis the oxygen concentration, and on the bottom this is the hours of the day. So this is the average concentration of oxygen for each hour of the day for the August months. And we can see with the red line that most of the time in August we are in stressful moments, and at the end we are even in the lowest tolerated range. To wrap up, the problem that we have at Aquaculture is that we have a variable oxygen level and seasonal temperature change, but we also have growth limitations because our sea bass can only grow for 7 months. In the winter, the temperature is too low for them to grow. And the oxygen is a big issue. As you can see on the right, we have the dissolved oxygen. So in blue, it's for the environmental oxygen, and in dark, it's the oxygen available in the cage. You have also in blue the current feeding time we use at Aquaculture. And you can see the first feeding of the day is pretty good, but the second one happens right when there is a drop in the oxygen in the cage. That's a drop that's not in the environment, so we link that to the digestion. And if you see the difference between environmental and cage levels, it's mainly due to nets and biofouling that's preventing a good circulation. Therefore, the feed that we send during this drop will be feed that will either be badly assimilated or not eaten at all, and this is feed waste. But that represents two main issues. The first one being that we send a lot of nutrients in the wild, so pollution and economic pressure, as the feed represents a huge expense, more than 50 to 70% of aquaculture farm expenditure in average. And for Aquaculture Can, it represents more than 2 million euros just for 2024. Our objectives are simple, but they are various. We aim to improve the production efficiency, minimize the environmental impact, but also optimize the feeding schedule to enhance the sea bass welfare and reduce their stress. Our hypothesis is that by integrating the oxygen levels forecasting with AI-driven strategies, we can improve the feed conversion ratio and therefore the fish welfare for the European sea bass at Aquaculture. For that, we set up 6 cages with three strategies across 6 cages. So we triplicate each. Each cage had 9,000 fish in them, and we fed them with the same feed from biomass, the robust feed. We had three strategies. The first one was the control, so the standard feeding that's used in Aquaculture. The cut two was increased intensity because the feed provider evaluate that we underfeed our fish, that we are still using the older table that were calculated ages ago, but that now with new formula, we have a better assimilation of the fish, so we can increase the intensity of feeding. And last one, the cut three, is the forecast. So we will send the feed only when the conditions are optimal. To have the forecast, we equipped the cages with the probes, oxygen probes. For the forecast cages, they received 2 oxygen probes at 3 and 5 meters to detect any stratifications. The control cages received just 1 oxygen probe to see the impact of feeding or activities. And on the bottom, you can see the forecast that we use. It's already being used in Norwegian farms for salmon, and it's been adapted specifically for aquaculture. Finally, the feed is distributed by hand. This is why we have traditional methods. This allows for real-time appetite check, so we can see if the fish are eating well. And the growth monitoring will use the tool by Innovacy, a stereoscopic camera that can give the average weight of the fish just by their size. And this will prevent stress because we don't have to manipulate the fish for the weight. Up to date, the trial has not started yet, but we have the cages that are ready. The fish has been transferred and we hand counted them to have the accurate count. We have the probes installed and working. You can see on the bottom the actual data. And the forecast starts to be used. The average weight of the fish is currently being done. And our results are obviously guided by research. But what we found is that pre-2000, they found 20% reduction in growth in hypoxic conditions due to reduced feed intake. In 2001, they showed a lower specific growth rate under hypoxic conditions again. And we think that maintaining a good condition of oxygen will increase the growth by 10 to 15% due to studies on similar species. Here it's salmon. And this is what we can expect from the growth of our fish. So for the first coat, we'll have the same amount as the second one for the feed used, but we get a bigger growth. And for the 115% feeding, we will not touch the FCR, but just the specific growth rate. It's important to remember that the test is not done in a laboratory conditions, so we have a lot of uncontrolled variables, like currents. We are in the middle of the bay, so if there is a storm, if there is rain or just wave, it can affect the results of our studies. But also that the test is based on salmon observations, and on the field we do not observe the same, because when we send the feed, as long as we feed the fish, they will eat even if the oxygen levels are not optimal. So the feed intake is good for us. We think therefore that the conversion of the feed is the most important factor, and that will point us to work on the digestion more than the feed intake. And also important to note that the nets are having a big impact, because at Aquaculture we are not using any toxic antibiofouling, so it impacts the oxygen dynamics. This is important. This study is important because just a 10% increase in growth could yield an additional 300,000 euros per year for Aquaculture, and this will justify further investments on oxygenation projects. The limitations, first, we had to run the construction delays. The sites we have 3 sites at Aquaculture. and the site at Lawrence had to be reconstructed. So it took a lot of time, and they had delays to follow and permits to respect. So that was the first main issue. Biological challenges, as we have to manage the parasites on sea bream that went earlier this year due to the high temperature, and also the transfer of the 50,000 fish that we hand counted. But as we took some delay, the temperature and oxygenation of the water was not optimal. The workforce has some limitations too, because we have to make sure that everyone understands why we're being so strict about the feed and why they cannot just have regular schedules. And the scalability issues, it relies on two main factors. The first one being the workers. They cannot feed every cages in few hours. And also because if we had to feed every cages at the same time, it could deplete the whole oxygen available. The recommendations, it will be that if it works, to apply the oxygen forecast for all the low oxygen sites, to work on best digesting windows rather than best feeding windows, to combine both codes 2 and 3, so forecast and 115% rations, to enhance the forecasts by using more data like currents or specific data. Auto feeders could be a solution for the best feeding windows that are not in our schedule. And finally, having emergency oxygen systems to prevent the stress caused on the fish during the worst moments. Thank you.
Thank you, Axel. So before we go for the question, I think you understood, you mentioned that there are different situations for students doing the master thesis. So you started your master thesis a little bit after the others, and currently you're in the process of continuing the master thesis, and you're going to submit your master thesis in August. So what you see here is only a milestone in your work. We'll open the floor to people online. Allez, Juliette.
Okay, thank you, Axel, for this great teaser. It was very interesting to see what you did, references, and so on. I have two questions actually. To your experiences, so how do you define the stress factor on the fish? So visually, are you able to say, okay, this fish is getting in bad condition and so on? How is work for you?
So for the stress, it will be more on the visual aspect. Every morning I'm going with the feeding team, so I have really a follow-up of the fish. I see them growing, and I can see them if they are eating well, if they are behaving differently. If there is any stress on them, we will see them when in the field, basically. And if we were not seeing that, we will see it in the data for their growth that will not align what we are expecting, for example.
Okay, thank you. And about the data, could you explain me a bit more how you can obtain this kind of data?
So, okay, so for the data, here, okay, so we will have a first average weight that's been done currently on the fish, so using traditional methods. And we will take, for example, 200 fish of a cage and weight them, see the distribution, standard deviation, to have some data. Compare that to what the camera from Innovasi provides. And if the data are similar, which is supposed to be the case because we are using it currently, yeah, that's how we will track the data during the the test, and at the end of the test, do another traditional hand counting of the average weights.
Okay, thank you. And I have just a very basic question. It was about the distribution of the cage when you choose. So it was in the first slide. If you can go to them, how did you choose the cage? Like, for example, so my question is like, okay, did you see that you will do 2 cage with code 1, 2 cage with code B, or you will have more a more better repartition? So what was your point about that?
The idea was to not have all the, for example, code 1, code 2, and code 3. We wanted to have them mixed to make sure there is no bias in the current, for example. So we wanted to have them distributed differently. And we put the 100%, 115% feeding in the bottom of the cage, because this is where we have less issues with the oxygen. So we want to have the focus mainly on the forecast for the oxygen.
Okay, and final question. So you speak about kind of innovation, how it's going. For your point of view, what is one of the best innovation? Is very hard to say like that, but what kind of innovation, to your point of view, could be very interesting linked to your internship? So, for example, you're missing data about something. You say, it could be cool to have this kind of innovation. I don't know, it could be sonar, captor, camera, and so on. What is your point of view about that?
You mean what kind of innovation in general could be applied in the test?
Yes, linked to your internship.
That's a good question.
For example, if you're missing of one of data, I don't know, because you speak about stress. So, for example, if the behavior of one fish is very suspect, do you think that I don't know, camera and then AI could help to this kind of behavior to detect it, or other kind of thing that you saw during your internship?
Yeah, sure. But we have to not forget that we are also a farm before being a laboratory, so the conditions are hard to meet the expectations too.
Do you want to elaborate? I think Juliette is waiting for.
Yeah, but I'm not sure of what
kind of fancy tool for Christmas you can ask for the farm.
That's the point. Thank you, Christophe.
Yeah, the easier would have been like oxygenation, but that would a bit ruin the point of the test, because the test is to first see the impact of oxygen and do we need to make further advancement for the project. But the biggest dream would have been to have oxygenation over all the cages to control exactly the oxygen levels.
Thank you, Axel.
Okay, let's go to you, Eric.
Sure. Thank you, Axel. Very interesting presentation. I will follow up on a similar questions on the relationship between the stress. You have two stresses that you present: is heat and oxygen levels. How do you know? So, do you know what do you know about heat stress alone? What does that do versus the absence of enough oxygen? Because you say that everything is caused by the absence of oxygen. And what is the component of heat itself?
So the heat itself will increase the metabolism of the fish. They will grow better, but also consume more food, and therefore consume more oxygen. But as you said, it's linked because the oxygen in warm water is less available. So yeah, I think evaluating the impact of direct heat will definitely be linked with the oxygen, at least in our conditions. It could be high. That's not something we can evaluate in the lab. Yes.
Okay, so there was some interruptions with the answer, so I'm not sure if I got everything. I think I got it. So my question is, so then perhaps do you know if some laboratory experiments have been done where they increased the temperature, bubbled the fish to see if this maintains the feeding behavior so that the growth rate continues?
No, I did not look into the heat specifically. We focused more on the oxygen.
Okay, because you said at one point that you hope that you can increase oxygen levels, right? So ideally you have a bubbler below the nets, and then you have enough oxygen in the nets. But then there's still, that's why I'm asking the question about what is the component of heat versus, because there's a level of heat stress that is sort of positive, and at one point it becomes negative. So, yeah.
Yeah, I think we did not look into that for now because the optimal conditions of the sea bass are under the 30 degrees, but we do not get above 30 degrees. So that's not an issue for now, but for sure for the future it will be really important and interesting to do that.
Okay, and then I have a question because I'm not 100% sure I got it. So you have two aspects. Once you say that you use or you want to use an AI-driven forecasting system that sort of regulates the amount of food that is dispensed, if I got it right. But at the same time, you are measuring the oxygen levels at 2 meters and 3 meters, right? So there's a real-time information versus a forecast. And so my question here is when is the effect on the fish observed when you have high temperature, low oxygen levels? Is it at this time or is it the day after, 2 days after? So how does the forecast come in play versus the real-time measurement?
How does the forecast work?
Come into play? So you say you want to develop an AI tool or that already exists from...
Yeah. The AI is more for the camera. So the idea with the AI to have no stress on the fish, to reduce the stress as much as we can, because every time we want to have an average weight on the fish, we have to put a smaller net in the cage, and we have to move the whole cage and then pick up some fish, weight them, put them out of the water. So it's a really stressful operation. Even if we weight just 100 fish, it will stress the whole cage and we can have them for days. So,
okay, then I mixed up the AI things. Okay, thanks. I will hand over, and if I have some time, I have another question at the end. Thank you very much.
Thanks, Eric. Let's go to Louisa.
Thank you.
Stay here.
I am.
For those of you just following online, you have to understand that it's maybe more than 35 degrees in the room right now, but we're still here.
I don't feel alone. But no, I was interested in what Eric just asked about the IA use in this case. How you already answered, and my doubt was about if you increase with this eventually directly communicating system the food, with how can you see then if effectively the growth increase? How do you plan to see it on the long term, eventually with the aid of IA, in the growth of fish will increase and
I mean, the question is about how we will compare the growth.
Yes, you are planning to use so this IA supported feeding method to increase the growth, or at least avoid the decrease that can be linked to this sort of oxygen. And so do you think that on the long term, here you are planning to do it in an experimental way, and do you think that this could be applied on the long term on large scale installations, as you were saying, with this system of automatic connection eventually to the feeding system, if it's automatic or manual?
I mean, everything is a question of budgets in the end, because salmon farms have already everything connected and they don't have to do anything. They have automatic oxygen systems. They have the auto feeder, and when the conditions are optimal, they don't have to touch anything. It's just driven by the technology. So of course here it's different because we are a little farm and we are not ready to have that much improvement at one time. But that's why we are doing this. As I said, it will justify if working only on the right times is already giving benefits. Then we can go see the director and be like, okay, with just the right time, you can make that much in a year. So if you invest even a few million euros in oxygenation system, you could boost by 20 or 30%. So yeah, that's the idea.
And what is the cost to, if I can ask?
I don't know if you can answer.
Of implementing and having to create this IA system that could eventually answer the, because we only think that IA is just for free, because actually there is a cost below for developing and
yeah, for the costs, I won't be able to tell you because we are partnering with the cameras. They gave us the camera to track the feed, and for the forecast system, it's similar. They gave us some probes and allow us to try the forecast that they were already using that was kind of paid by the salmon. So we're just getting...
Yeah. Maybe a couple of questions.
Thank you very much. I'm not sure to catch this information. You don't use any oxygenator for in the cage?
No, at the moment, no. And the complex thing is, I think you will see better on this slide. So this
Coming.
Thank you. So this is our site, and these are the cages. This is the main site, so where we have all the logistic, and we have no acidifications, we have no currents on the cages. So for now, it will be really complex. So it's just floating blocks that are assembled to make the cages. So yeah.
Okay. And the new site that is under construction, it will be the same?
No, the new site, yeah, I didn't have time to explain better, but there is 3 different locations at Aquaculture. There is one at Lérance Island, one in Cap d'Antibes, and one here on the picture, La Batterie, which is in the Bay of Gulf. And this is the one that has the main issues with the oxygen. So the one that was relocated, they made it in deeper water with better currents, so they don't have any issues with oxygenation or even warm temperature.
And the cages are quite big. You put only 2 oxygen probes inside. Did you check the homogeneity because the fish is moving in the cage, so it's a little bit strange to put just 1 or 2 probes. Do you map a little bit the oxygen repartition in the cage during the time or anything?
I mean, we have 2 probes to detect the stratification. So as I said, because with the forecast, we don't want to send the food when there is oxygen, but maybe there is oxygen at 3 meters, but not at 5 meters. So that would be a mistake. And we can see on the graph, on the screen on the bottom, AB C, D, and E. And we have similar conditions for the cages. There is a little change, but that's pretty much similar. And the little variations that we see is what I explained with the currents and the location of the cage.
We have time for 1 or 2 questions from the guys.
Or not.
Yeah, of course I will be. Just reactivate everything. And Nichele.
Well, thank you for your presentation, Axel. I'm interested about knowing about this virus that you mentioned because I don't know much about it. Will you guys visually assess it? And if so, how does it affect the fish?
So here I talk specifically about the Noda virus, and it's a big issue that Aquaculture has, and each year they are losing quite a big part of their production, and we don't have much to fight against at the moment. We only know that having good conditions, the feed can help too. If we have some complements like iron, it can help to have better immune system for the fish. Yeah.
Maybe Adrien was also asking.
Yeah, I just wanted to know if there was any other kind of parasites, like for the salmon, they have salmon lice. I don't know if for sea bass it's the same.
For sea bass, we don't have issues. What I mentioned was for sea bream, and you have some pictures here. So that's on the sea bream, not the sea bass. And there is some sort of
on the gills
larvae, and they are on the gills here. And we use a specific feed to fight them. Yeah.
Okay, good. Maybe you can pass and take some water on your head if you want.
Yeah.
Congratulations, Axel. Congratulations everyone. Ah, c'est la tienne? Ah ben je crois que oui, je crois que j'ai vu dans ta bouteille. Donc la question oui la mienne, je sais pas. And so next, I'm happy to welcome Fabian. Hello, Fabian.
Hello, everybody.
Ah, Fabian, I don't hear you.
wishes
Maybe
for
you
the-
have to mute and unmute your microphone.
Still not? It
No,
did
the
work
microphone
before.
is not working. Try to
We
mute.
can hear him actually.
You can hear me?
I
I
do.
think I've got it. They have to unmute and it's good, Fabian. No worries, no stress.
Okay.
We see part of you, sometimes all of you.
Yeah.
Fabian, can you tell us where you are and what time?
I'm
it is?
in Cebu, Philippines, and it's a bit past 8:30.
Okay.
Long day.
All good. So we're all good. You should see your slides and you have the floor.
Okay.
Yep.
Yeah, it works. Awesome.
But just
Is it?
hold
Does
on.
it also look
Just,
messed up for you, the title, or is that just on my screen?
yeah, I don't know why I have to.
Because in
I
my
have-
PowerPoint it works well.
It's your
Maybe I
screen,
can.
so I'm just sharing your screen share.
Okay, in that case, I will just do screen share instead of using that stream function. Give me a sec. Okay. Does it look better now?
I guess it's loading. I'm afraid we don't see you anymore.
I hear you again. Can you see my screen?
That's coming. Oh, good. Let's go.
Okay, technology. Okay, so bienvenue and welcome everybody. I'm presenting my thesis that I did with Climate Foundation here in Cebu, Philippines on seaweed biomass and carbon flux in marine permaculture and how to cost effectively quantify its potential for marine carbon dioxide removal. You probably feel in Nice right now, we're in big trouble concerning climate change, and this disproportionately affects subsistence seaweed farmers in Philippines who have contributed very little to the problem, yet are hit very hard by more frequent disasters, such as the big typhoon in 2021 that did massive damage. And to be clear, there is absolutely no substitute for immediate and drastic cuts in carbon emissions, but carbon dioxide removal will also be necessary on top to limit warming below 2 degrees. Various approaches are being explored for carbon dioxide removal on land and at sea. Among these, nature-based blue carbon solutions such as seaweed farming, and one special form of this, marine permaculture, is what we are talking about here. Permaculture means the conscious design and maintenance of ecosystems for sustainable provision of human needs, but in harmony with diversity, stability, and resilience of these ecosystems. And this is what our deep cycling permaculture, marine permaculture arrays are designed to do, providing many benefits for food security, biodiversity through habitat provision, and a massive potential for carbon removal in the gigaton scale. Works like that. The seaweed gets lowered into deep, nutrient-rich waters overnight and back up for photosynthesis in the day. And here we are in the world's largest deep cycling marine permaculture array, a 1/4 hectare off the coast of Cebu. And here you can see it with these solar-powered subtractor buoys in the corners. And this technology allows for much more productive and climate-resilient production compared to conventional methods. For example, when a typhoon comes through, lowering it to just 5 meters depth can prevent the storm damage. The main species of interest were red seaweed Capophycus alvarezi and the filamentous ulva, especially the ulva meridionalis, which is extremely fast growing. And for all these reasons, marine permaculture could contribute big time to global carbon sequestration. The challenge to address is monitoring, reporting, and verification. We need scalable quantification methods to access carbon markets that could help a lot financing to bring it all to a meaningful scale. And this is exactly what my study set out to do, developing low cost and scalable methods of precisely quantifying carbon, well, biomass, and with that carbon flux in seaweed in marine permaculture, and doing so using just consumer grade RGB camera drones. RGB stands for red, green, and blue channels. So these are just regular cameras. And more precisely, a machine learning benchmark is being developed for estimating this seaweed biomass change, positive change, so growth, and also negative change like falloff rates, harvests as well. And I assumed, as the green seaweed is really dominating our array, it's very visible in the images, that the greenness in these images and the area covered up by green seaweed in the images would be detectable even by human eye, so that by human eye I can tell when comparing pre and post harvest images and detect the biomass loss. It's led to the research question: how suitable is consumer grade RGB camera drone imaging for precise estimation of seaweed biomass flux? And the initial hypothesis, H1, that there is a significant positive correlation between biomass change and segment mean green intensity change. Bear with me with the segment. I'll explain a few slides. And the second hypothesis is almost identical, but with area change covered by seaweed instead of the green intensity. To answer this research question, 3 branches of data collection were started with a Mini 4 Pro, DJI Mini 4 Pro. High-resolution images and slow-motion video were captured. Then physical measurements for seaweed biomass, so the harvest data, then weighing data, and also fall-off data. And then complementary environmental data from various sources is the 3rd branch that would be used more for future studies and the model training. Our very particular use case that required particular methods that largely had to be developed from scratch, and also specialized material needed to be identified or manufactured, all with low cost and replicability in mind. And back to our deep cycling array, this was divided into 4 color-coded quadrants, and a 3-banded color code provides unique identifiers for each individual tube net of interest on the array. More details here. Unique identifiers were also necessary for our sediment trap rotation schedule. Those were used to measure the fall-off rates, and the rotation schedule was necessary to limit systemic bias due to prevailing currents more from one direction. On the right, you can see one of these sediment traps in action under the array. And we had 2 pairs of that in operation so that we could do hot swaps, and one being cleaned and processed while the other one is collecting, also allowing intraday and overnight comparison. Next position in the rotation schedule would be then this, just as an example. And I developed a standardized protocol for the processing. On the right, you can see some examples we found in these sediment traps: seaweed, also some jellyfish, and mostly fungblennies, little fish that live in the tube nets. Documented and then frozen for use in another separate study currently. A protocol was also needed for the weighing and harvesting schedule, ensuring homogeneous water content, pretty much 90% that we had after full immersion of the seaweed and 30 seconds of draining. And lastly, also for the drone data collection, always starting and landing on the same spot, 2 meters above sea level, flying out the 3 kilometers to the array, taking an overview image from 50 meters, then close-up shots from 15. With some practice, you can get very fast at it. And the DJI Waypoint mission feature was used for the spacing.
Guess we lost him, huh?
Yeah, good to know it's not on our slides. We'll just allow Fabian a minute to come back, I guess.
To manually annotate the tube nets of interest and then export in JSON formats for further processing in Python, which is also compatible with machine learning workflows, object recognition, and such. Here on the top, you see for the full image, and below only the segment that I showed you, the mean channel intensities, average intensities for red, green, and blue channels was a good sanity check to see that the green intensities were higher in the only segment compared to the full image. And several challenges in the processing. Once the glare or reflectivity of the water required to shoot at a minus 45 degrees angle. And to correct this distortion, this foreshortening, we had a geometry correction. Then even in just the blank water without any seaweed in it, the channel intensities, they varied a lot with just the light intensity, irrespective of biomass change. And to limit the influence, I conducted a baseline subtraction just of the mean intensities of some background annotations. This is how that looked like. So removing most of the blue, red becoming much more visible. And yeah, with all these steps that I needed to teach myself and conducting them, that was very time consuming. So I ended up with a rather small sample, only 9 image pairs pre and post harvest. So non-parametric spearman rank correlation was used, two-tailed, and also leave one out cross-validation for regression analysis. The results you can see here. From top to bottom, it's ranked by correlation strength, weakest on top, strongest on top, weakest on bottom. Green is positive and red negative correlations. And you see the strongest we saw with the segment mean green intensity change. So 0.85 spearman row, highly significant, even with such a small sample size. And then closely followed by the blue intensity change. And this is not so surprising because there are also a lot of blue pigments in the ova. The corrected signal was accounting for the geometry correction as well as the background subtraction and the area change. And these were correlating a bit weaker, at least with this small sample. Zooming in on our strongest correlation, both axes show change. So you have 0 on the x-axis for no change in intensity, and then further to the left, decreasing intensity of the segment mean green intensity. And on the y-axis, the difference in over biomass. So this is negative change. So the further down on the axis, the bigger the harvest was. And you see a positive correlation. Single predictor. That was the best performing model with a cross-validated R-square of 0.46. So bad for this small data set at least. And what to make of all these results? They seem very encouraging for carrying on our data collection. And to answer the research question, the first hypothesis, I could reject the null hypothesis at 95 confidence interval. For the second one, this was not the case. And altogether, there's really a clear signal and a high potential for using these consumer-grade RGB camera drones for seaweed biomass monitoring. There were a few methodological innovations as well, but also limitations. So most notably the time, just iterating through various steps for all these protocol was very challenging, all in parallel. Ideally would have been split among several researchers, the responsibilities, but yeah, it's like this, we just ended up with a small sample size. But even with just this pilot, this little start that it is, it serves as a proof of concept and allows us to say that it has a high potential. It seems technically feasible to do that only with RGB camera drones, and cost-wise, it's accessible, especially when the processing time comes down with automation. And moving ahead, continued data collection, open sourcing our benchmark for the community to develop the machine learning models, and ultimately perhaps including other data sources. Many thanks to everybody who made this possible, and also to you for your attention. And now it's time for questions.
And so I give the floor for questions to the members of the jury, starting on site, as we started online last time with you, Adrien.
Thank you very much for your presentation. I am trying to understand what is the purpose of this production.
I'm very sorry, I hear you so silently. Do you have a microphone in the room, perhaps?
The purpose of the seaweed production.
Yes, it's to do what?
The purpose. So there is a lot of potential, many options. Right now, it is used for biostimulants, but of course, many culinary and other appliances as well down the line.
So the next part of the question is, why do you speak about carbon sequestrations? Because finally the time life of this seaweed is very short. You collect it and she will be disaggregated for some reason, and so where is the carbon sequestration?
Yeah, so parts of the seaweed will naturally sink down even if we use it for commercial processes. And depending how deep they sink, this can be sequestered for hundreds or even thousands of years. And yeah, so this is a huge, the huge potential here lies in enabling commercially profitable seaweed cultivation also in far offshore deep waters where this potential is at its maximum.
It's why you have sediment traps. It's to monitor this part.
Exactly, yeah.
Okay.
This is one of the methodological innovations. So sediment traps have, to my knowledge and those of experts in the field, not yet used to monitor seaweed fall off, but it seems promising as a tool.
And maybe a last question. You say in ulva there is blue pigments. Which one?
That I didn't look up, but there is definitely also blue present in the ulva.
Okay. Thank you.
Mm-hmm.
Thank you, Christophe. Okay, yeah, I was going to ask also about the purpose of the study. I mean, I understood that it's interesting to quantify the biomass of an aquaculture, and that potentially new techniques can be done in a more efficient way. But yes, I was a little bit confused, maybe because also it was online and the connection was not perfect. If you are more quantifying the biomass in the sediment traps, or you also want to quantify the biomass with the drone about the production. And I wanted also to ask about the link with carbon, and but if you can start with this, just to
Sorry, just the last part of the question. What about the carbon?
Sorry. No, about the carbon we'll speak later.
Okay, so yeah, we are interested in the biomass flux, and from that, in future steps, we will calculate the carbon flux. But first of all, it was about the positive change, so the growth, and then we also know how much we harvest. So, and but as I said, part of it, estimated 20 to 25% perhaps, sinks down. And this is particularly interesting for the carbon sequestration aspects of it. So yeah, we pioneered a novel approach of quantifying this fraction.
It was mostly amateur, but did you consider, for example, that this organic matter, because we call it carbon, but finally it's organic matter that is exported from the aquaculture to the another system, organic matter exportation. Did you also consider in your model that this will be degraded, as Iber was saying, that could eventually have some modifications in the ecosystem, in the water column, or when reaching the bottom, the benthic environment? And when do you think that this carbon, as you talk mostly about carbon removal, when do you think that this carbon could be considered removed from the atmosphere?
For the second part, it is always removed when it's photosynthesized, but the question is how long, and this is highly dependent on how deep it sinks. And in short, we have to study this to answer all these questions to satisfaction, and this is why we conduct all this research, because we just don't know enough about that yet. I know that people are skeptical about such approaches, and I'm sure it's good practice to first test and research in smaller scale to really know what we're getting ourselves into, and making sure that the solution doesn't make everything worse.
Yes, but you know, there is a controversial about the use of large scale. I only have one more question.
You have time. I'm not looking at you.
A controversial about using seaweed that is quite important. There is a rich literature about this, about using seaweed as a carbon removal, because of the actual likeliness of success, because of fertilizing with nutrients that would be necessary in the open coast, and also because of the effects that would be potentially observed that are not known, as you are saying. So do you think, which part of this do you think you're more, I think you're more prone to push for this kind of nature-based solutions in the context of carbon removal, but what do you think should be the next step to really assess, to say, okay, maybe it's worth, what would be the priority of future research in this context, before trying to eventually quantify the amount exported, and without trying to understand the fate of this organic matter in the other systems? What is, to your opinion, the priority, the things that really we have to know to say, okay, it's worth investing money and energy in this? Bye-bye.
Elle était trop longue ta question.
No. Fabian, I'm still here. Fabian.
I'm terribly sorry. I did not try to evade the question. The connection worked very well as long as it was only YouTube with the new stream.
Very well, yeah.
I'm sorry.
Fabian,
so,
what's the
can you please repeat the question?
What's the priority in research now?
The priority in research?
For using the seaweed offshore, especially farming, as a nature-based solution for carbon removal.
Yeah, there is just much more area in the sea that suddenly becomes available, and the background is in many regions around the world. For example, here the Philippines, seaweed farmers are struggling a lot with the rising temperatures, and it's threatening their livelihoods. So this, just going a bit further out and accessing the deep nutrients and cooler water down there might really help. Did that answer your question?
We have to go.
Oh,
yes, I know. But I'm sure you will be able to continue interacting. But Juliette, to you.
Okay, thank you, Fabian, for this presentation. And firstly, I would like to say a great job to just present Julva results. So about species, can you explain me a bit more how different seaweed species contribute to the carbon sequestration? Like, in your bibliography, did you see that there is different kind of carbon sequestration in function of the seaweed species?
Yeah, definitely. There's very species dependent, but I did not have the capacity to dive super deep into the comparison yet. It is quite a new field, and so I really focused on what we are growing for now.
Sure, but just I know that you did a lot of bibliography. Did you see, like, for example, okay, Ulva, I think it's very interesting because they are growing so fast. But can you imagine seaweed growing less, like not so fast, but sequestering more? I don't know.
Giant kelp is, of course, very promising as well. It's also fast growing, and yeah, for the ulva, unless it sinks down into the deep waters, maybe other species are more interesting. But with our innovative technology, having just the fastest growing multicellular plant that fourfolds in biomass in one day under the right conditions has massive potential. And I mean, it is not the only option to just have part of it naturally sink down. You could also think about creating biomaterials for that are used in construction or shipbuilding or whatnot, and like that bind the carbon for a longer time.
Okay. And so about this innovation, very cool to understand and to see what's happening. To your point of view, do you see other opportunity of taking this innovation into other sector? I don't know, like the other presentation with about aquaculture of fish. Can you imagine this kind of innovation in this kind of field, or not so much?
Definitely, especially for fish feed, replacing some of the bottom trawled fish meal and fish oil that is used way too much for aquaculture. It has immense potential. It is species dependent, like you cannot just go put every fish in the world on a 100% ulva diet, for example, but there are many species for which you can actually replace a big part of the fish meal or fish oil. So this is a very good combination. Also, I would love to see this combined with integrated multi-trophic aquaculture.
Okay, my question was more the innovation that you developed, like with drone and measuring the sediment sinking, stuff like that. Do you think that this kind of innovation can go into another field?
The biomass monitoring with the drone, definitely.
Yeah.
I mean, honestly, other sectors are far ahead of us in precision agriculture using multispectral drones and all that. So it's more the other way around right now, that we still can learn from other sectors. But there is a lot of other applications.
Okay, and during your work, you did some bibliography about that. I can understand if you know about other sector. Anyway, and I have a final question. So for you, Fabian, what was the part of the research that you prefer, the more exciting part, the more challenging?
What I preferred, clearly, the field work, being out on the array and freediving. The learning to operate the drone was also really cool. And yeah, I guess these are my two favorites. More challenging, definitely the learning all these image processing. That was a huge rabbit hole, and I'm sure there's still a lot more to learn.
Okay, thank you, Fabian. I leave the floor to Eric.
Merci. So I continue right away. Thanks, Fabian, for the interesting presentation. I have a question. Perhaps I missed it, but so it's a seaweed farm, right? So
yes.
They harvest the seaweed regularly. So what is the added benefit of having a drone and a machine learning machine to tell them what the biomass is versus they harvest every 3 months and they know exactly how much tons of algae they harvest?
So you have to differentiate between production and the biomass that is being produced, because as I mentioned, parts of it are also sinking down, especially that's our assumptions that we will test with all the complementary environmental data that we have collected, is that with stronger waves and stronger currents, you would see more fall off. And this is basically the difference, the missing part of the equation that you would not see if you only measure the harvest. But we need to quantify that to know the blue carbon potential. Okay.
Thanks for the precision. The second question is, and I guess you don't have the data yet, but there's an increasing concern about using machine learning AI because it's so energy consuming. So you release a lot of carbon because of that. So, and this comes back to the question that we already asked about the question potential of the seaweed. So do you have an idea of the cost and benefit of using this kind of approach? Because if you want to sequester 1 ton of CO2, but you use 2 tons of CO2 to calculate how much biomass you have produced, the net result is not really worth it. So do you have an idea? Is it something that you have taken into account?
You raise a very good point. Thank you. Not yet, because it is also, I mean, we are not at the finish line yet. Still, we have collected tons of data, but the pre-processing will take more time to really know the entire workflow from start to end and how work intense it is, how expensive it is, how carbon intense it is. But thank you, that will be interesting to analyze.
Okay, I'm good. Thank you very much, Fabian.
Just a question on my side, Fabian, I'm curious, how deep are the sediment traps?
The sediment traps are about 1 meter below the array. So of course, with the waves, you don't have 100% precision. So this is also an interesting point you're raising with some limitations as of for now, because depending on the current, you would see different tilt angles, meaning you have a different aperture with effective area where we effectively collect the fall off. So this, we are still discussing how best to account for that. For now, it's just a limitation, but it's a start, yeah.
And maybe somehow coming back on Ruiza's question, how deep is the water there? And so, I mean, how deep would this algae have to go down and could be degraded through the water column?
The seaweed goes down to about 120 meters, but this is, yeah, depends on the size, on the site, and yeah, where you see the thermocline and the nutrients. And yeah, around the areas, you soon have 500 meters depth.
Okay, you have 500 meters below the...
Not directly below, a bit further out.
Okay.
It's more like 120 and between 100 and 200 is what most sites would probably...
We have a minute for questions from here. Joran?
Yes, hi Fabian, can you hear me?
Yes.
Okay, I was wondering for your AI what your sample size was, because I did something quite similar, also used biomass prediction and used AI for it. I was wondering how big your training data was to analyze this.
So I have not yet applied machine learning to it, not even for the segmentation and the annotation of the tube nets, but the data that we've collected until now is at least 50 pre-post image pairs that after pre-processing should also go into this pipeline, and that can also be paired up with good harvest and fall-off data. So yeah, most likely we will need much more than that. And my first trial will be training the object recognition algorithms with my segmentations, my manual ones. What about you?
Well, I didn't use AI, but I was just like...
Good. Thank you. I think we're good. So congratulations. Thank you for being with us. So it's now time for us for a break, and we're coming back with Adrien, but at least here on site. So if you want to see Adrien, you have to be in this corner with us, because it's not going to be online. And we'll finish with Nichele. And anyway, you will not be able to come because it's a private, confidential, only for VIP people. So congratulations again, Adrien.
Thank you very much. Have a great day. Good luck to everybody else.
Coming back in 30 minutes at 3:50. 3:50.